Good afternoon, everybody. Brian Culotta here with Train by Tex. I have a 2015 Hyundai Sonata here, and the customer concern is the check engine light is on. They had mentioned that they just had the vehicle at a dealership for a check engine light, and the fix that they performed was a flash update for the code that it currently still has. It has a P200A intake manifold runner performance trouble code in the engine control module. Now, the only thing that was performed by the dealership was simply a flash program. There were no parts changed or anything else, just a simple flash update. I will demonstrate at the end of the video a Automotive Test Solutions Intelligent Induction Cleaner. That is the 3C machine. I'm going to demo this on this vehicle. I just received this tool and I'm kind of excited about it. I want to see how it does. This is one of the first vehicles that I've used it on. The first one being my own personal car, and this specific Hyundai right here will be the second car that I've used it on. This is a GDI, and I do suspect that I have carbon issues on this engine. Now, moving along here, in service information, I pulled up the DTC description of the trouble code that I have. It says the PCM sets this trouble code if there is a deviation between the actual position of that VCM flap and the target position of that VCM flap. If there's ever a difference between where it wants it and where it actually is, it's going to set this code. Now, while I am in service information, I went ahead and I looked for the flash update or any technical service bulletins that I could find to see why they flashed this PCM. And I come across this TSB right here, and it says exactly the code I have, P200A, intake manifold runner performance. And it says at the bottom, confirm the proper operation of the Vcm Actuator and replace it if necessary. If it does not pass your inspection, then go ahead and replace it. And then at the end, it says update the ECM. So whether or not you replace the actuator or not, we're going to flash this thing no matter what. But we need to prove that it can actually work before we go ahead and flash it. Now, what is a Vcm actuator? VCM stands for variable charge motion. Now, this is a electric motor with a position sensor that's built into it that is bolted to the side of the intake manifold. And its job is to move an intake runner within the intake manifold to create a swirl effect in the intake manifold. Now, this motor has two wires, which are simply the motor control for the actuator. And there is also 3 wires for the position sensor that is built into it. Now, the position sensor's job is to determine where exactly this flap motor is, so it knows if it's in the correct position or not. You know, I've commanded it to a certain spot. Did I actually get there, or is there a problem? That's the whole purpose of this position sensor. I am a lab scope guy, so I'm going to go ahead and put a lab scope on this position sensor to see exactly where the signal return voltage is at, to compare it to the specs that I have in the service information. I'm going to go ahead and back probe on the yellow wire right here and just compare it to what the position of the sensor reports in scan data. Now, real quick, this is what the actual motor looks like when you unbolt it from the intake manifold. It's simply bolted on with 3 bolts. There's a lever here that connects to the linkage for the for the actual butterfly of the intake manifold, and it just simply moves the butterfly open and close to change the position of the runner control inside of the intake manifold. That flap door happens to look like this on the very exit part of the intake manifold. The very part that bolts to the cylinder head is what you see right here. That is a flap door. You can see the size of that port has been reduced to a much smaller size. That's going to effectively increase the velocity of the air going into the cylinder head. Okay, so first things first here. I have, with my Snap-on Verus Edge, I have pulled up the VCM motor control. Now I want to see if I can physically move that VCM motor, and at the same time I have below the scope capture that I was telling you about. Alright, so real quick, I know we have covered this before in another video that we've done, but I'm going to tell it again just because I like doing this test. It's kind of nice having the ability to have a lab scope and a scan tool on one tool at the same time, viewing both different aspects of what's going on at the same time. It's kind of nice. Not many tools can do that. So I'm going to begin just by explaining it. To be able to do this, you have to, in the beginning menu of your Snap-on scan tool, the Veris Edge that I'm currently using, you're going to select Component Test. And once you pull that up, you can do it's called a signature test, which is going to pull up your lab scope. Now, it doesn't necessarily matter what part that you choose for a component test. You can choose anything you want, a crank sensor, TPS, it doesn't matter. All I'm looking for is to be able to get that scope screen pulled up on my screen, because once it's pulled up, I can then minimize that screen, which effectively detaches the scope screen from the scan tool's scanner suite, and then now we can have multiple windows on the scan tool. As you can see here, I have one minimized menu of the lab scope, and then I have one maximized window of the scanner. So I'm basically doing two things at once. And what I'm going to do here is actuate the variable charge motion motor. I'm going to actuate that and just see what the position of that motor is. The image you're looking at here is the result of the after effect of what I had to do to get that motor to move. Now, when I began this test, that actuator did not move. It didn't move at all. It squealed, it bucked, it kind of made some noise, but it didn't move at all. It did not physically move until I grabbed a long pick or screwdriver, and I physically helped it move. And the moment I got my pick on there and I gave it a little nudge, the actuator broke loose and was just fine. It was moving back and forth, like you see in this capture on the screen. This video right here, you can see once this starts that the position is going up and down, up and down, up and down, as that actuator is opening and closing, opening and closing. And in the background here in just a moment, you'll see, it's kind of blurry, I apologize for that. You can see that the actuator is moving right there. You can see it. And that's just proof that the actuator now is moving after I helped it break loose from its closed position that it was stuck in. So it looks like I have a good diagnostic direction at this point, that the actuator was probably stuck. What could possibly cause it to be stuck? Usually in my experience, that is caused by carbon buildup on the actual butterfly that's inside of the intake manifold. So the next thing that we're going to have to do is get authorization to either just remove it for inspection, or to see if we can clean it, or to see if the manifold should be replaced. So I'm going to go ahead and remove this intake manifold. Now, if you're an efficient tech like we all wish we all were, you're going to get this intake manifold off, and I'm just going to say you're going to wish you were this fast, but I don't think any of you are this fast. You know, I basically get this manifold off in like 10 seconds. Maybe 15. Go underneath the car, take the shields off, take the 2 bolts that hold the intake manifold on. There's 5 bolts on top that hold the manifold to the engine, and voila, the manifold is off. And you can see right away that the butterfly that is on the manifold, that the part of the manifold that bolts to the head, is carboned up. There's carbon on that part. Turn a light on here, there's carbon right there, you can see it. I go to each runner, you can see it. It's pretty carboned up, and I'm going to wager to bet that is what's going on. I'm going to try physically moving that with my hands, and you can see it's kind of stuck. I had to use a lot of effort just to get it to move. So I think it's safe to say that we need to sell an intake manifold. This is kind of excessive carbon. I don't think I'm going to want to spend, hours trying to clean this manifold by hand and then hope that the actuator did not get damaged because of the binding that it's been under, the conditions that it's been in for such a long time, that that actuator has gears inside of it that could have broken. There could be a return spring that's worn out, all because of the extra effort it takes to move this physical door. So I have the intake manifold off. Again, I just got this 3C machine. I want to see it work. I want to see the before and after results of it working on a GDI vehicle. And since I already have that manifold off, I'm going to inspect the intake valves. You can see a photo here. This is one of the cylinders that I had taken an inspection of, and they don't look too bad for a GDI vehicle that has carbon on the intake. I was expecting these valves to be much dirtier than what they really are. Now, I will say that it took a lot of effort to get this photo. I have the intake manifold off, and the camera is right in front of these valves. I can see it with my in plain view with my own eyes without a problem at all. But for whatever reason, focusing on these valves was very difficult. I mean, maybe need a better camera. And right here is another valve on a different cylinder. You can see there are some deposits on this one. And I'm going to have another picture here in just a minute of another valve that is a little worse than those two previous. This one right here, this valve, you can see there is a layer of carbon that has built up on the actual flat surface of the valve. That is, in my opinion, a good time to do this cleaning. I have not developed a misfire yet where walnut shell blasting or a manual chemical scrubbing of the valves would have to be performed. I think the main benefit of this 3C machine is the fact that it's going to clean valves as a maintenance item rather than a repair item. When you get to the point where the thing is running so bad that you have misfires, I'm not confident that the 3C machine is going to be able to handle such a load like that. It may take a couple services. Maybe it will be able to clean a lot of the carbon, but personally, I don't think it's going to work. I've done walnut shell blasting before. I've done manually cleaning before, and that's a lot of material that you have to take off. And I don't think that just spraying the chemical on there is going to take care of it. But again, I just got this machine. I have not experienced anything with it yet other than my own vehicle, which was not a GDI vehicle. This one is. So let's see what happens. Okay, so the new manifold was sold. The new manifold is here. I'm going to briefly compare the difference of the movement between the new manifold and obviously the old manifold. And you'll see right away this intake flap moves very easily, and not only does it move very easily, but it returns. I'm going to rewind that one more time. It returns by itself. I don't have to physically move it back to its home position. It springs back to its home position. And it does it very, perky, very snappy. And to the old one, I got to really push to make that move, and it does not close on its own. So it's safe to say that manifold should be sold. That manifold does come with that actuator as well, so it's kind of a one-piece deal. You get everything you need. It's going to be, it's going to be fixed when you get done. All right, so the next step would be to get this new manifold on. I want to put the new manifold on because I want to be able to run this 3C chemical through the engine to clean those valves. That service was sold, as well as the intake manifold replaced. The customer was understanding that the carbon that you see on the intake manifold is also the same carbon that you see on the back of the intake valves. And he was agreeing that this service should be done. I showed him the photos of the carbon on the valve, and he was in agreement to go ahead and do the service. So what I have to do is put that new manifold on, and I think the whole benefit of having the new manifold on as opposed to having the old manifold on in the sense of the cleaning process is if I'm spraying that chemical into a manifold that's dirty, a lot of that chemical is going to be used to clean the manifold. So in my case, I have a new manifold to go on. Let's go ahead and put that on. That's going to make the chemical going into the engine as virgin as possible, or as potent as possible, to giving me the best opportunity to clean those valves. So, like a speed demon that I am, I go ahead and get that manifold back on. This is actually the removal video, but you get the point. Alright, so now it's 3C time. Time to get our 3C machine out. Time to put the chemicals in, hook it up, and I'm going to demonstrate how I made the connections of the 3C machine real quick. Chemicals A, B, and C were gotten off the shelf. There is a three-part. This is a three-part service, so all three chemicals will get used, and they get used in a sequence. They're not all used at the same time. It'll take the chemical it'll take chemical A, and then chemical B, and then chemical A, chemical B, chemical C. There's a sequence, or there is a sequence that the machine will basically inject this chemical into the engine. And you will use the contents of all three of these cans. They are, I believe, 16 ounces, so you're putting a whole bunch of chemical through this engine. I have done many different fogger type intake induction cleanings in my career, and I will tell you that the one that I did do on my own personal vehicle was the most intense fogger system that I've done in my career. You have to keep this engine at approximately 3,000 RPMs. The machine is going to beep at you every 20 seconds, and at that 20-second mark, you're going to have to snap the throttle twice, as illustrated in the instructions. And the whole point of that is to prevent chemical puddling inside of the intake manifold. You want to make sure that the chemical doesn't puddle in the manifold, so if you were to leave the shop, you wouldn't have a whole bunch of chemical just sitting in the intake manifold, and then all of a sudden the engine decides to gulp all of that chemical and potentially cause a hydrostatic lock in the engine, potentially doing damage. That's not something you want to do, which I think that's the whole purpose of the 20-second beep that this machine has, is to try to evacuate the chemical that may be puddled up in the intake manifold. On the back of the unit, there is the three cans that the chemical goes into. Each one of those cans is labeled A, B, and C. Obviously, you put the appropriate chemical in the appropriate can, and but before you do that, there is an air bleed button on the back of it, and now that's important to bleed any remaining air pressure that may be in the system before you go ahead and remove those stainless steel cans from the back of the unit. You wouldn't want to have chemicals sprayed on you when you're attempting to remove them. So go ahead and push that air bleed button, and then you can go ahead and remove the cans from the machine. The next video, I'm going to show you how I connected the special hoses that the machine has. Now, when you get the 3C machine, they give you a whole series of special hoses that you're supposed to use with this machine. They don't want you to use any adapters that you may have laying around. The whole purpose is to not use. The whole purpose is to use what they offer, because you don't want the chemical to deteriorate any not compatible type plumbing or hoses that you may have laying around that could cause some damage while you're doing the service. The last thing you'd want is one of your own hoses or something breaking or coming apart and spraying chemical where it shouldn't be spraying. So it's important to use what they offer that the machine comes with, and it comes with a whole bunch. There's all different sizes that it comes with. It's kind of nice. Real quick, I'm going to connect my special hose to the intake manifold, and I happen to choose the little line right here that is attached to the purge solenoid. Now the steel line that you can see going to the left, or it might be right, I'm not sure how this video is going to process, but either way, you can see the steel line that it goes into. It goes to the bottom of the intake, which is right near the throttle body. It's kind of a nice central location for the chemical to be dispensed into. You wouldn't want to dispense the chemical into a port that may only feed one intake runner or something like that. You want to try to find a nice central location that is, of course, the straightest shot into the intake manifold. In this case, it's not ideal. I do have a couple bends. There's a 90-degree steel bend right there. I understand that that's not ideal, but there honestly was no other better spot that I could find to dispense the chemical into the intake manifold. And one other note is the intake fogger system does not spray into the ported vacuum part of the induction system. You want to be into the engine manifold. You want to be under vacuum. This does not go in front of the throttle plate. It must go behind the throttle plate. You must be in the engine vacuum for this to work. Here's my connections to that pipe. That pipe comes down to the bottom of the intake manifold, and that's the connection I'm going to make to the 3Z machine. The end of that steel pipe connects to another piece of rubber hose, which goes to that nipple that is on the intake manifold. That the throttle body will bolt right to this green gasket right here, so that's a nice central location. All of the air that would naturally come into the engine is going to go right where this 3C machine is going to dispense the chemical. So I'm going to wager to believe that's the most central location that I can use. So it's, I think, going to give me the best overall results. And you can see here that port, again, it goes right to the center of that, where the throttle body, where it was. So there should be, again, a nice central location. One other step in the instructions, it mentions to take a look at the intake manifold to see if there's any runner control valves. This specific manifold has not only the electric manifold that we were talking about, but it also has this vacuum actuator at the bottom. There's two different ones. So I have the electric one physically opened, and I have the mechanical one with vacuum actuated as well. The whole idea is to keep that manifold as open as possible to kind of reduce the puddling potential in that manifold when you're performing this service. This manifold is kind of the shape of like a ram's horn, where the air enters the bottom and kind of swirls around and then has to come up to enter the cylinder head. So naturally, if there's any liquid, it's going to puddle at the bottom of the intake manifold and then have to be fed upwards to get into the engine. So it's important to do every step you possibly can to make sure that you're feeding the engine properly as the liquid is being sprayed into the manifold. Here is a photo of that vacuum actuator that I have physically moved. All right, back to the machine. You'll see you'll have a big red button in the center. That is basically the on-off valve. It's an emergency stop, but it's also the switch to turn it on. You have to rotate it to turn the system on. Once it's on and the machine is full, you have to select the amount of cylinders that you're performing the service on. Is it a 4-cylinder, a 6-cylinder, or 8-cylinder, 10-cylinder? You know, whichever. These settings basically change the amount of liquid that's being sprayed into the engine. So you want to make sure that you choose the correct one. I'm doing a 4-cylinder, so I'm going to go ahead and choose 4-cylinder on this car. Once it's turned on, there is an disarm button that has to be pushed. And then when you're ready to begin the service, you're going to go ahead and click the Start Clean button. Once you do that, the system's going to beep, and you have to get in the car and basically keep the RPM between 2,500 to 3,300, I believe it is. Basically around 3,000 RPMs to begin the service. While you're doing the service, every 20 seconds the machine is going to beep, letting you know to snap the throttle. And the whole idea, again, I believe, is to evacuate any potentially puddled chemical that may be in that manifold. So here I am, keeping the RPMs at between 25 and 3,500. You can see it kind of like surging, and I believe that surging is every time that the system decides to spray some of the chemical in, the engine will naturally kind of lower in RPM as it inhales more chemical. And then it'll let up a little bit, and the RPMs will climb, and then after 20 seconds, you'll hear it beep. Okay, I do my 2 snaps, maintain the RPM. You can feel it kind of bog down as the system adds more chemical. The whole idea is to keep the RPM, approximately 3,000 RPMs while you're doing this service. As time goes by, you'll hear again that 20-second chime to snap the throttle, and I would say about 15 minutes later, the service will be completed. One thing to keep in mind is if you're going to perform this service, to either do it outdoors or use some type of exhaust evacuation system to remove that chemical, because this thing is going to fog a lot, and you obviously don't want to fill your shop with some harmful fumes. You want to make sure you get rid of that exhaust from the shop. Obviously, this is not something you want to do in the winter with the doors closed and no hose to the outside. You want to make sure that you get rid of that smoke. One other note that I'd like to mention is the instructions tell you to use a large fan in front of the car, and the whole purpose of that is to not only let some air flow through to keep the engine cool, but also to keep the exhaust cool. You're not going to want to overheat the catalytic converter. You want to try to keep the system cool. And I have been told that this chemical works best when it's cold. You don't want the engine to be hot. You don't want the chemical to be hot. You want this to be as cold as possible, and that's going to give you the best results. So the engine has been cold. I have not ran it up until this point. So the chemical's cold, the engine's cold, everything is textbook in that case. Alright, so now I'm going to head and remove that intake manifold again, because I want to re-inspect those valves. Again, this is the second time I've used this 3C machine. I want to just prove to myself that it works. I want to see it clean, or at least cleaner, before I can confidently sell it to a customer. I need to see that to sell with conviction. To actually prove that something works, I need to see that it can work. So I'm going to go ahead and remove that intake manifold again. Again, this manifold was pretty easy to unbolt, and when I put the new one on, I purposely kind of left all the connectors and everything kind of loose. I only put on a couple bolts just to hold it against the engine, just to kind of hang it in place, and it came off in 10 minutes, and you'll see here it only took me 7 seconds to get it off. So zip, 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 zip. Get that manifold back off, and then we're going to go ahead and inspect those valves once again. And you'll see right here, this is the after. This is the intake valve that I originally showed you. That was the worst one of all in the before pictures. That was, you could see the physical scale on top of the intake valve. Currently, that scale is now like an ash. It's much drier. The valve, in my opinion, is not, spotless by any means. It's not pretty. Keep in mind, I have not driven the vehicle yet, so some of those deposits may come off as I test drive the vehicle, to try to take it up on the highway and thunder run it, if you will, to try to remove any of these remaining deposits. I'm not, I'll be honest, I'm not as surprised as I was hoping I would be. I was hoping to find a nice clean valve. This valve was not that dirty in terms of a lot of the valves that I've personally manually cleaned myself with walnut shell blasting or manual cleaning. Obviously this one didn't need it nearly as bad as a lot of the ones I've done in the past, but there were deposits before I started, and there still are a decent amount of deposits on there as well. So this is just my experience. I'm not demoting or promoting this product. I'm just sharing my results with you. If you do not have the machine and you're inquiring about its capability, well, this so far has been what I've been able to produce. It seems like the deposits have certainly become more dry and potentially could flake off the valve. They're no longer sticky or tarry. If that makes sense. Sometimes the carbon builds up and it's so sticky from the oil and saturated with oil that it kind of just sticks there and hangs on that valve forever. Maybe this chemical is good at drying it out, so it can basically dust off of the valve. And that's basically all I have for you guys. I wanted to share my excitement for the 3C machine and the before and after of what I found. Obviously this vehicle is fixed. It's the runner control is now working. A majority of the deposits have been removed. I did test drive the vehicle after, and I put a decent amount of miles on it because the customer was looking to get his emissions test done, which requires me to drive it long enough to get the readiness monitors to be completed before I can test it. So I had to put 15-20 miles on this thing to get those monitors to be completed, and of course the check engine light remained off and all the monitors did complete, so I was able to pass this thing for emissions, and the customer was returned his car and he's happy as can be. So this is not a uncommon problem. I've personally done a handful of these manifolds myself. Some of you have probably done it yourself too. I'm not trying to show you some shocking case study or something. I just wanted to show you what I found and the results before and after of the new machine that I just got, and share it with you all. So again, thanks for watching. You all have a good evening.